Hi everyone and welcome into this new video in which I continue my Windows Privilege Escalation series. Specifically in this video we start to see a practical example on the service attack area, and specifically we will talk about weak service permissions. So if the services are not properly configured, so if they have weak permissions, we can attack them in two different ways. We can attack the service configuration, or we can attack the service binary itself. So these are two different aspects that both have to do with the weak permission, with the configuration of weak permissions. At the end of the video, I will also show how to enumerate the service with winPEAS. So this can be useful if you want to have quick results, a quick overview over the service of Windows. You can use winPEAS with some flags that I show at the end. As always, I hope the video is useful. If it is, leave some feedback. Even if it isn't, leave some feedback. Subscribe to the channel to help me grow and share this video with like-minded people. Having said all of this, please enjoy the video. So let's start our discussion on the first type of weak permission, which is a service configuration. So when the service configuration itself is weakly configured. So we saw in the previous video where we discussed about services that we can enumerate, we can obtain the configuration of a given service with the command cs.exeqc. So we do cs.exeqc and then we put the name of the service, and in a practical example essentially what we get is we get this kind of output. So we have a bunch of different like configuration. And among these values, one of the most important one is the binary path name. It is the path that points to the binary associated with the service. Which means that, for example, take this example, simple service. We have this simple service exe found in C users quickemu downloads. What does it mean? It means that when we start the server, we are actually executing this binary. And in the previous video about services, I also show how to create a simple service using the Windows API. So the idea is, what if this configuration is not properly set up with the right permissions? What if it allows our user, the user over which we have access to the machine, what if we are allowed to change this configuration? Well, the basic idea is really simple. If we can change this configuration, if we can change specifically the binary path name, we can just point to a different exe, maybe a malicious exe that contains some malicious code, and then we will just be able to execute our code. So the idea is that if we can change the configuration, and then if we can stop and start again the service, the new executable will be executed, which is gonna be malicious, of course, because we have control over that. So how can we obtain this kind of information? Well, a quick and easy way is to use the access chk64 binary, which is a utility that Windows offers to download. So you can go into this site. So by going into this website, you can download the binary. It is around 1 megabyte, and it is a Windows utility which is very useful, so you should have it. So in my case, I have it here essentially. So in content bin, I have this access chk64. So the first thing is, let's bring it to the remote machine. So as always, I'm gonna put that ncat to just transfer it. Very, very simple. So here I'm gonna open a shell, and the shell has to be actually cmd, because otherwise the ncat is not gonna work properly. I go into downloads, and I'm gonna change to the Italian keyboard here. Then I'm gonna do nc. I'm gonna put the IP address of my machine, and then I'm gonna put access csk64exe. So I'm getting a connection here, so it's been transferred, and so now I can just use it. Perfect. So we have essentially the reports effective permission for secureable objects. So this is like a very general utility which we can also use for services. How do we use it for services? We can just say, you can just use this command, which has a different flag, so we will explain it later, but let's just copy and paste this here. So I'm gonna do this here, and look, it says, look, simple service, it's the authority system has access to all the service in read and write, and also the administrators. So this service can be accessed by authority system and administrators. So essentially that's the basic idea. And here I report essentially the various flags and why we use them. And also we have to do this accept eul, also that we don't have to write all the time accept essentially. So specifically, okay, let's say that we have this kind of configuration. Now my user, if I say who am I, actually if I say who am I / groups, I actually belong to the administrators group. So since my user belongs to the administrator groups, I should be able to change the configuration of this service, given that the administrators can do everything with the service. However, let's try, for example, to change the path, like with this command. So this actually does not change anything, but let's just try to access the service in this way. So I'm just gonna take this and I'm gonna copy it. It says actually access denied. And I believe, I'm not 100% sure, but I believe it has to do with the medium mandatory level, which is a Windows security feature, which I describe in the second video of the series when I talk about Windows permissions, and I have this integrity control. Essentially, the idea is that you can have different integrity levels, and depending on the level, you have only access to certain features. This means that even though my account technically is part of the administrator, this particular shell was executed with a medium level, and this does not allow me to access those privileges. Indeed, if I say winPEAS in this shell, I don't have much here. However, if I go and do cmd, if I search cmd here and then I say run as administrator with the same account essentially, now I'm still QuickEmu. However, if I do winMy groups, I essentially am high mandatory level. So now the level has increased, which means I can now change the configuration of the service. So if I go back to the things to change the configuration of the service, I can just do this. Okay, not this because it did not copy it correctly from. So let's clear this. So I'm gonna copy this, I'm gonna paste this. And now it changes correctly. So at this point, we can assume we have a user that is able to change the configuration of a service in the system. And also we're able to stop and start the service. So we can do stop, simple service. It's gonna say the service has not been started, and we can also start it. So with this shell, we have full control over the service. We have these capabilities: starting, stopping, and changing the configuration. Perfect. What can we do with this? Well, a first payload is, let's say that we already have a malicious netcat binary in the Windows system. This is not really malicious per se, but we will use it in a malicious way. So what we can do is we can change a binary path to essentially trigger a reverse shell. So it's a very simple payload. Look at this. We just change config. Here we put the netcat. Here we put the IP address of our attacker machine, of our attacker endpoint. So 192.168.122.1.431, which is the TCP port. And then we do -e and we give the program to execute over that TCP connection. So this is like a simple reverse shell. So let's listen on this specific endpoint 431. And let's change the configuration like this. And I'm gonna put the shell here down so it's you can see it better. So let's execute this. So I'm gonna copy it again here. I'm gonna put it here. And now I've changed the configuration. However, I still do not get code execution because even though the configuration has changed, and if I check it with QC of simple service, I get, look, this is the new binary path name, I still need to start it to actually get code execution, because when I start the service, I'm gonna actually execute this specific command, which will trigger a reverse shell. So let's start it. Simple service. It's not QC, it's SC. It's SC, I always forget myself. And notice what I get down. I get a reverse shell as NT authority system. So now I have all the privileges of admin, essentially, of the root user in Windows. And so this is a very simple way to obtain code execution, given, however, that we can change the configuration of a service. And at the end of the video, I will show how to enumerate this thing with winPEAS. So that's a first approach. What would be maybe a second approach to exploit this, just for completeness? So let's say we don't have this malicious netcat already within the remote machine. So what we can do, we can use MS Venom to create a malicious payload like a shell reverse TCP with a given host and port. We can say, look, I want an executable and I want to call it malicious.exe. So let's exit from this reverse. So let's exit from here and let's remove this malicious. I'm gonna regenerate it with MS Venom, and here I put the payload Windows shell reverse TCP. So I'm just gonna do this. It's something about the future deprecation, but we don't care about that right now. So now I have the final payload. So essentially here I did not put the architecture, but the architecture chosen by the payload is good enough. It's x86. So that's a 32-bit architecture, which works for our case because Windows also supports that. And if we check the file on it, notice we see it's a P32 executable. So this is a 32-bit executable. It's still good enough. So what we can do about it is, okay, let's transfer it to the remote machine. So let's go into downloads here. I'm gonna do an end cut as always. Oh shit, I always... Okay, end cut with the right port. And then I put malicious.exe. So malicious.exe, perfect. I've transferred it over, that's good. So let's try to just use it to make sure that it works. So I'm gonna listen on port 777 and I'm gonna execute it with my user, malicious.exe. And notice I got a shell. So I got a shell and of course here I am quick-emu. But of course this quick-emu runs with the integrity level medium, so like I don't have access to all the privileges of administrators, but I still have a reverse shell. So now to make the actual attack on the service configuration itself, what I can do is, okay, I can change now the service configuration with this other shell, and I put, okay, the new configuration is going to use this malicious.exe. So I'm going to copy this, go here, take the shell with the higher integrity level. So I'm going to put this and put this. I have changed the configuration. Now I can stop the service. So I can do stop. Before doing start, I'm gonna have here, let's open here a reverse shell. So I don't know why this shell is stuck. Okay, I'm gonna open here a reverse shell. Actually, let's do 3. Perfect. It's port 777 this time. So always be careful about the ports. And so now I can do start. And when I do start, actually, let's first see the configuration itself. So if it's properly changed, c.exe qc simple service. Notice now that it points to the malicious exe. So we can do cexe start simple service. And boom, we have our shell. So this runs as authority system. I have all the privileges and I can do whatever I want within the machine with this specific shell. Also, notice this one thing. We were able to obtain a shell as NT authority system because the way this service was configured was that it would log on as local system. So this is why it's important to like configure this stuff, not local system, not network service, but local service if it is a service that only runs on your specific machine. So essentially that's the idea. And so this first attack has to do with the essentially service configuration, with how the service was configured. Now, let's say that you are not allowed to change the configuration of the service itself. However, you are allowed to change the binary of the service. So this has to do with different kind of permissions, not on the level of the service, but on the level of the binary. For example, let's consider this. So let's start the service. So we can do, we can actually, okay, let's go back to the original service. So let's configure it back to the original value like this. I put it here. So let me copy it again because sometimes it just does not work. Okay, so now I have the previous service, the old service. I'm gonna start it, simple service. So perfect, it started. Now let's execute this command, get sim instance class name win3 services, select name state path name where object is like running. So this is a command in PowerShell that we can use to obtain all the running services and their binary path. So we do this and we have essentially a bunch of different services, and among these we can find essentially at some point where is the SS simple service with the binary path C user quick-emu downloads. We can say, oh look, this service starts in a user's directory. Maybe we can change it. Maybe we can change the binary itself. So how would we test for it? Well, the idea is that let's use the ICLs utility to get the configuration of the specific binary. So can we modify this binary itself? Can we overwrite this with a new binary? Can we just change it whatsoever? So we copy this command. So we just copy this command here and we can say, look, let's go here. I'm gonna go into downloads because that's where the simple service exe is found. And then I just execute this icalcs. And I get, look, I am the user quick-emu. So I am the user quick-emu this, and I have full control over the binary. This means essentially I can overwrite it. So at this level, we are not really changing the service configuration. We are changing the binary itself. You can sort of think of like, okay, the service configuration points to the binary. So the way to attack this is either we change the service configuration and we point to a malicious binary. So this is what we showed previously. Or we just overwrite the original with a malicious and we don't change the server's configuration. So it's still gonna point to the same binary name with the same binary path. However, the actual executable associated with that particular path in the file system, the content of that executable will be different, and specifically it will be a malicious one that we overwrote because we have access to this binary, because this binary was not properly protected. So that's essentially the basic idea. It's pretty simple idea, so it's not too complex. So once again, what can we do? Well, we have already generated the malicious. So really the only thing we need to do is just copy it over the simple service. So we can stop the simple service itself with the other shell. So we can do start and stop here. So we can do stop. And of course, in this case, I'm showing two different shells simply because in one, I've just the normal user. In the other, I have the more privileged user for starting and stopping the service. This requires having the privileges to start and stop the service. If you do not have those, you cannot really explore this attack vector. So here we are assuming we have compromised an account which can start and stop services. These are threat modeling. This is the point where we begin our exploitation. Here I'm just showing two different shells because the first one that I opened simply had the lower mandatory level for accessing all the privileges. So that's the idea. So we have stopped the service here. Now we can overwrite this service, even with this lower privilege shell, because we are the same user after all. So we can just do this copy, very simple command. It's gonna take the malicious, which contains the executable for a reverse shell, and it's gonna overwrite the simple service. Look at the sizes. This is 41, this is 73K, and now after this, we do a dir again. They are, of course, the same. We have overwritten the original service. Now, of course, here I did something that is kinda dangerous. I did not do a backup. So before you want to do this kind of thing, especially in a remote environment, you want to do a backup. So you want to say, look, I'm gonna copy the original one into a backup version, and then I'm gonna replace it. So actually this one, it would be like this simple service. First, you do a backup of the original executable and you save it somewhere so you don't lose it, and then you replace it. Because let's say that something goes wrong and essentially you fuck up the service, you want also to get back to the original version. If you overwrite it but you don't save a copy, that's very dangerous. So always do that in case. I didn't do it because I've saved the simple service in my Linux machine, so I'm not really in the previous directory, not in this one, so I'm not really worried about that. So having said that, it's as simple as that. So like we're already done, because now we just need to put our listener at 777. We're gonna stop the service, already stopped, we're gonna start it again, and look at this, we have a new binary. Even though if we check here, if we check the configuration of simple service, it has not changed. Now we did not change this configuration, but we changed the binary itself, and now we have a shell. Once again, the shell runs with an authority system because this is a system service. And so with this, we are essentially done. The last thing before closing the video is, other than a bunch of references that I've used for preparing the video, which I thank all the authors that made them. So essentially, we have enumeration with winPEAS. So we have this project winPEAS, which allows us to enumerate the service attack area of a Windows system. And how can we use this? We can just download it with wget. So look at this, it's a very simple command. So I'm gonna do exit. Here I have it already, winPEAS x64. So it's just wget with the GitHub page, the download page. This is the version, the 11 October version, whatever. Then we transfer into the machine. So simple netcat to transfer it over. Our favorite command, and see 127.122.143 winPEAS.exe. Actually, let's do it like this, so it's better. Okay, so we have this. Now we have the binary itself, not access, but winPEAS. And okay, it's actually doing a lot of stuff. We don't want to execute everything. We are mostly interested in the Windows service enumeration. So how can we use this winPEAS to enumerate the Windows area? We just do winPEAS quiet services info. Very, very simple. We just do this. And look, we have a list of services that we can start or stop. We can start or stop these specific services. It says, look, these are the interesting services, like non-Microsoft ones. And look at this. It tells us that we have file permission over this simple service. And also the configuration, if it stopped running and if it's auto, like if it resets at boot time, so it starts again at boot time, or we have to manually start it essentially. So that's the idea. So it says file permission, quick cam access, all access on this particular file, and then possible DLL hijacking, which we will cover in a different video, so watch out for that. And then we can modify these services, and there is no registry we can modify. This ones if we are able to write permissions, but we are not with this specific shell, we are with this other, however. Like with this other, let's try to execute the same script on this other. So user quick ammo download, and we do we have to do cd, of course. So user quick ammo downloads, and then we do winPEAS, we do quiet services info. Of course, here we do not have the graphics essentially, but we are able to write data. We are able to modify all the registry entries, of course, because we have full access to the system. So the output is much more rich, clearly, because we have way more access essentially. But that's the general idea. So in this video we show two simple ways to attack services, either if they have misconfiguration on the service itself at the service level. We can check that with the access CHK. Remember though that sometimes, even though our users belong to certain groups, if our mandatory level, which I discussed in the Windows permission, this mandatory integrity control, this MIC, if the MIC is medium, then we cannot really access certain privilege features. So that's the idea. But other than that, let's say that we find a service, we know we can start and stop it, and we can change the configuration. Then the idea is just to change the binary path. It's a very simple idea. And another way is that, okay, let's say we cannot change the configuration of the service. However, we can overwrite the binary that the service points to. So the binary that is actually executed when the service starts and stops. If we can change this binary, once again, we have control over code execution on the system essentially. And then we can just create a shell. We can create a malicious exe with MS Venom. We can upload it to the remote machine. We can overwrite the original service with the essentially with the malicious one, and then we can start and stop. We can stop it and start again to obtain code execution. Of course, at this level, we're not really talking about obfuscation and about avoiding antivirus and like endpoint detection systems. That could be the topic for future series. Maybe at the end of this series, we'll talk a bit about that. I still have to decide. However, for basic stuff, we assume there's no antivirus, and then we build on top of this knowledge in the future. So essentially, that's the idea. And finally, I show how to enumerate the specific service area with winPEAS. So it's a very useful tool. It's a very useful enumeration tool. So this is it for this video. I hope it was enjoyable, I hope it was useful, and I hope you got something out of it. If you did, leave some feedback, subscribe to the channel, share this video with like-minded people, and see you to the next video.